So I think there's a huge opportunity for the ski industry to really seize on sustainable tourism, and that's becoming popular in other parts of the world in terms of recreational tourism. And I think the ski industry has a real opportunity to really grab on to this idea about sustainability and educating the public about it. I think a lot of the major ski resorts are already doing that. The Steamboat Ski and Resort Corporation has been partnering with the Storm Peak Laboratory through the Desert Research Institute to forge new understanding of climate science in a very major and impactful way. And so I certainly, the ski industry uses a lot of energy, it uses a lot of water, it generates a significant amount of waste. And I think in general, the ski industry is pretty aware that they want to be responsible stewards of the lands that they manage and to sort of, think globally and act locally. So just to the left of us here is the Mid-Mountain Snow Stake, where the ski corporation observes the data that they report on the website. And then over here to my right is a stand of trees where we have a number of instruments that are placed to measure snow depth in different conditions, different slope angles, different positions with regard to trees. And that's giving us information about how representative this measurement right here is. And so the ski resort is actually interested in understanding, where should snow measurements be made in the context of informing the public about how much it's actually snowed. Now, the scientific enterprise that we do that's very unique here at Steamboat is focused on understanding how clouds affect climate. And the biggest source of uncertainty in global climate models about how the climate will change in the future, our biggest lack of understanding is the role of clouds. Clouds are white and bright, so they reflect a lot of sunlight from the earth. So that is a cooling effect on the climate. But clouds also trap heat. And so that gives them a warming effect on the climate. And the net effect, whether or not those clouds have a net cooling effect on the planet or a net warming effect on the planet, is that biggest source of uncertainty in how the climate will change in the future. And the detailed physics that goes on inside of clouds those are the critical processes for understanding how the climate will change in the future. And here at the top of Steamboat, we're able to make measurements of the processes that go on inside of clouds because we're actually up inside the cloud. And to do that where you're not in a mountain system, you have to charter an airplane and make those measurements in an airplane that's flying through the cloud. So it's a very unique environment that allows us to have much easier logistics than using an airplane, in that we can ride up a few chairlifts and get into a building where we have instruments to measure the processes that go on in the context of cloud formation and the formation of ice crystals within clouds. So inside of a cloud, you have water vapor, you have water droplets, and you have ice crystals. And the growth of those ice crystals occurs through processes that we actually understand very little about. And that growth process has a big impact on whether those clouds have a net warming or cooling effect on the climate. And so here in Steamboat, we have some very unique measurements for measuring the properties of those ice crystals and the dust particles, and in general what we call aerosols, that are at the center. They're called they're the nucleus of the ice crystals. And so here in Steamboat, we're able to observe these ice condensation nuclei, to observe what they are, how efficient they are at forming ice crystals within clouds, and how they affect overall amounts of snowfall. One of the things that's unique about the work that's been done here and the setting here is that we have a number of coal-fired power plants upwind of this location along the Colorado Plateau. And so one of the things that we've really wanted to understand is associated with how the particulates that come out of those coal-fired power plants impact amounts of snowfall in the Colorado River Basin. And one of the interesting results that's come from work here at the Storm Peak Laboratory that I personally was not involved in, but I'm aware of because it's a very interesting and important finding, is that with the enhanced aerosol loading into the atmosphere and abundance of ice condensation nuclei within clouds here, it reduces the total amount of what we call riming. Riming is when supercooled water droplets in clouds freeze onto ice crystals. And snowfall is enhanced greatly if you have more riming. So if you get more of these water droplets freezing onto ice crystals, those ice crystals will grow more and they will fall out of those clouds more efficiently, and you'll get more snowfall as a result. Now, because we have this abundance of ice condensation nuclei within the clouds because of these coal-fired power plants, we reduce the amount of overall riming, and so we end up with more ice crystals, but with lower mass in those ice crystals because there's less of the water droplets freezing onto them. And as a result, they don't fall out of the clouds, and more of those ice crystals and snowflakes are carried over the mountain range into carryover or spillover into the adjacent watershed. So it actually changes where the snowfall occurs. And so you actually can get less on one side of the mountain and more on the other side of the mountain.